So let's talk about TCP and UDP in detail. So first of all, we'll talk about user datagram protocol. The details of user datagram protocols for a developer can be are given in request for comment 768. So we have also already covered it that UDP is not adding much into the services that are provided by the IP, because IP is connectionless, internet protocol at the network layer is connectionless, and UDP is also connectionless. So it only extends host-to-host communication provided by the internet protocol at the network layer to process communication. So we have already covered that UDP segments may be lost, can be delivered out of order. It also provides us best effort delivery. Then there's an obvious question that why do we use UDP then? So there are certain reasons, and by the way, there are many applications that make use of UDP, like DNS, RIP, Routing Information Protocol, SNMP, and there are many real-time applications that prefer using UDP. Why? Because of the following reasons. Number one, UDP is critical for the performance of some of the applications because we don't need to establish a connection first. So if we have to establish a connection, so for example, if I take a TCP for an example, so I have to establish a connection using three-way handshaking, right? So I'll send a message segment to the server machine. It will be responded by the server. Then I'll again send another segment. Means I'll be sending three segments before establishing a connection with the server. So there is no connection establishment cost in this case. So this really makes it fast as compared to TCP. Then since there is no connection establishment, I don't need to maintain any state of a connection. So what do you mean by state? In the case of TCP, I have to maintain sender and receiver buffers. I have to maintain sequence numbers and acknowledgement numbers of these segments that are that are transmitted or acknowledged. So there's no such state to be maintained in the case of UDP. And UDP has, in a minute we'll see, UDP has a small segment header size, only 8 bytes. So it takes less time to be processed, and that's why it's fast. And we can always have a finer application control over the data transmission. Means UDP is, yes, connectionless. There can be losses, out of order delivery of segments, but this can be controlled at the application layer by the programmer. Obviously, this will be adding complexity into the application. It will be a challenging task for the programmer of an application. So if we look at the TCP segment structure, remember we just talked about that about the UDP segment, or the segment at the transport layer. We said, broadly speaking, it has two parts: a header and a data field. So here we are trying to expand the header. We would like to see what are the different fields in the header. Remember, I told you there are different fields, but two fields are very important. One is the process address of the sending machine, and the other is the process address of the receiving machine. So we have destination port number, and then we have source port number, and then we have the length, the total length of the UDP datagram, including header as well as whatever data that is coming from the application layer. And here we have checksum. Checksum is used for error detection. We'll be covering checksum and other error detection mechanisms at the data link layer. Here I have two questions for you to be discussed in our online session. What do you think? Why do we need to have these port numbers, these process IDs? Because operating system is already generating IDs for the processes that are running in a machine. So what do you think? Why do we need to have separate process IDs? So let me write it here. Why separate process addresses for network application processes? Network application process. So I would like you to discuss this in our online session. Secondly, this error detection mechanism is also implemented at the lower layers. What do you think? Why do we have to implement it at the transport layer being part of UDP segment structure? So we also do this, error checking at data link layer. What's your take on this? That we are also doing it at the transport layer. So this is the second question that I would like to discuss with you in our online session. So I've already identified there are many real-time applications that make use of UDP, user datagram protocol. Why? Because these applications are loss tolerant. Remember, UDP is connectionless, and you can see there is no such information in the header of this UDP segment that talks about the acknowledgement or reliability. It's a very simple 8-bit, very simple, uh, 8 bytes header. Very simple, right? That's why it's fast, easy to process. And these applications are rate sensitive because this time is important here. The rate at which we are sending the data is important. So that's why many applications, real-time applications, multimedia, streaming applications prefer using UDP, user datagram protocol. But on the other side, about 75% of the real-time applications are using TCP also because of the reliability it is providing. So it entirely depends upon the designer or the programmer of the application to make a decision either UDP is required or TCP. Other protocols that makes use of UDP is DNS, SNMP, RIP. By the way, here for the source port number, we have 16 fields. This means we can have in total 65,535 total port numbers. And out of these 65,535, the port numbers from 1 to 1023 are standardized, right? For example, we have port 80 for HTTP, we have port 25 for SMTP, and we have port 21 for FTP, right? And the other details we want to look at can be seen in RFC 3232, right? Regarding what? Regarding the assignment of port numbers. Okay.